Hello friends, Agrawal is Assistant Professor in Civil Department, Sandipani Technical Campus, Latur. Today's topic is show that bending moment at any section of 3-inch parabolic arch is 0 when it's subjected to UDL throughout the span. Now the learning outcomes. After watching this video, student will be able to calculate the support reactions, and also a student will be understand the concept of zero bending moment in 3-inch parabolic arch. Now this is our statement. Show that bending moment at any section in 3-inch parabolic arch is equal to 0 if uniformly distributed load W, a kilonewton per meter, is acting throughout the span of the arch. Now first we draw the loading diagram. Now suppose this is the arch having support A is a hinge, then support B is a hinge, and third is at the crown C hinge, the A, this is a B, and suppose this having the length the L, and this having the rise H. Now this is subjected to UDL throughout the length. And this intensity this is W, kilonewton per meter. Now here, now the first step is to calculate the support reactions. Support reactions. Now here, for that we have to, for our sake of convenience, draw this as a simply supported beam. And apply this UDL throughout the span. This is support A and this is support B. So here the reaction is the VA and here the reaction is the VB. Also here the horizontal reaction H on both the side, and this arch is now. So here by symmetry of this arch and load is symmetry, we can say that if you apply the sigma Fy condition, sigma Fy equal to 0, so here we are considering the upward force positive and downward force negative. So here upward force is a VA, then VB, and downward is this UDL, that is the W, kilonewton per meter. So here is the total load is a WL, and that is equal to the 0. So here we know this VA and VB is equal to 0. So we can say that VA is equal to the VB. So VA plus the VA, that is equal to the W into L. So here we can say that VA is equal to the WL by 2. Because VA is twice VA, so VA is equal to the WL by 2. Now next is to find the horizontal reaction, that is this thrust H. For that we have to take the bending moment at the crown. So bending moment at crown, and that is equal to 0 because of the hinge. Because here at this point there is a hinge. Now bending moment at a crown. So always whatever bending moment is, so beam moment minus the H moment. In our case that is equal to 0 because this is the bend moment is at the 0. So beam moment is here, we are taking a moment at here. For beam moment is what? VA into the L by 2. VA into the L by 2. This is the positive, and here this hogging bend moment is minus W into L by 2 into L by 4, and then minus H moment, that is the bend moment at here. So here this H into this the H, and this always create the hogging bend moment. So we can see that here is minus H into the H is equal to 0. So now here W is equal to the WL by 2 into L by 2 minus WL square by 8 minus H into the H is equal to 0. So this becomes WL square by 4 minus WL square by 8. If you take it right side, that becomes H into the H. So divide this H here. So we got here H is equal to WL square by 8H. So in this way we got the value of the reactions horizontal, that is the H is equal to WL square by 8H, and here also the VA is equal to VB. So this VA is equal to the WL by 2. Then next we have to prove here. The question is what? A bending moment at anywhere in the arch is 0 when is subjected to UDL throughout the length. So now we are taking here the bending moment at any section is the X. Also here is the X. So always we know a bending moment at any section X is equal to the B moment minus the thrust moment or H moment. So first we write the B moment. So bending moment at the X is equal to beam moment minus the thrust moment. Now beam moment is now how? Here this is VA into the X, because here this VA into the X, because this our moment is at distance XX, and minus this W into the X into the X by 2. So we can say that VA into the X minus the WX square by 2. This is the B moment. Then minus H is the H into the Y. How this Y? Here this height is the Y. This height is the Y. Now in case of this parabolic arch, now here, right, in case of this parabolic arch, in case of parabolic arch. Now suppose this is the arch and this is the hinge. So it is from the X, from the hinge support here, and this is Y. So Y is equal to 4hx by L square into L minus x. So this is anywhere Y in the parabolic arch is from the support is Y is equal to 4hx divided by L square into L minus x. So here we have to put here. Now VA is equal to, we know, is WL by 2 into x minus WX square by 2 minus, here H is equal to how much is WL square by 8H. So WL square by 8H into 4HX by L square into L minus X. Now is equal to, here is H. Now this H and this H gets cancelled out. This L square and this L square gets cancelled out, and this 4 is the 2. So we can say that here is WL by 2x minus WX square by 2, then minus W into x by 2 is remaining here. So W into x by 2 in bracket is L minus x. So finally we can say that WL by 2 into x minus WX square by 2 minus this multiply here, so that becomes WL by 2 into x, this minus and this minus plus, so plus WX square by 2. Now here we can say that is equal to, now this is the plus WLX by 2, it is a minus WLX by 2, this gets the cancel out. This is a minus WX square by 2 and this is a plus W square by 2, this gets the cancel out. So this is the 0. So bending moment at any distance XX in the 3-inch parabolic arch, when is subjected to UDL throughout the length, the bending moment is the 0. And this is our requirement. Thank you.